Hey everybody, Dr. A here, and in this video we're going to be exploring another example of 2D rigid body equilibrium. So let's go ahead and get started. In the given information, we're being asked to compute the external support reactions. Now here we're given a simply supported beam, which if we recall, a simply supported beam has a roller at one end and a pin connection at the opposite end. Now this beam is 10 feet long and it's supporting a distributed load that has a parabolic shape. In particular, this parabolically shaped load is concave up and has a load function of 0.2 x squared plus 10. And the function itself carries units of pounds per foot. So that's what this symbology here means. W has units of, the triple equal sign means has units of PLF. So we see that the origin is given to us as point A, positive x is measured as pointing to the right, and then positive w, of course, is moving up like this. The initial point at point A has a load value of 10 PLF, and then, of course, we have this parabolic increase up to another value, a higher value at point B. If we wanted that value here, the value of W, all we would have to do is substitute in 10 feet in for X. So that would be 0.2 times 100, and then which is 20, and then plus 10 is 30 PLF. So we could pretty quickly see that the value of the load on the right side is 30 PLF. But again, we don't really need to know that per se. We just need to know the load function, which we are given that directly. So let's go ahead and tackle the solution. We're going to start by drawing a free body diagram of the system, just like we know how to always do. So by drawing a free body diagram of the system, I've got the beam here, and we have this parabolic load distribution here. And we know that the reactions here are AY at the roller, and then at point B we have a BY and a BX, and we know that the length of this is 10 feet. I'm just going to put that right there. And then, of course, we know the load function is, W is a function of X equals 0.2 x squared plus 10, okay? So we can look at this and immediately hopefully we'll notice that if we sum forces in the x direction, we call things pointing to the right 0, we'll see that Bx comes out to be 0. So that's a pretty trivial part of the solution. Now, how do we get Ay and By? Well, this is a non-uniform load. It's also non-linear. So in order to get Ay and By, we're going to need to use the integral form to compute the resultant force of this parabolic distribution and its location, okay? So let's go ahead and write that out. We're going to say that the equivalent force of that parabolic distribution, F equiv, is the equivalent force of load distribution. It's going to come from taking the area beneath the load distribution, which in this case we have to use the integral form. That's going to be the integral from 0 to L of W as a function of X dx. So for our problem, that's going to be 0 to 10 feet of 0.2 x squared plus 10. And of course, that function has units of PLF dx, okay? Now, this is a pretty easy integral to take. If we want to show our work here, just to, remind ourselves how we take a simple integral, we can do that. But, you can also punch this in your calculator. If you have a TI-36X Pro, this can do it pretty easily. So this is a polynomial. We raise it a power, and we divide by the new power, right? That's our rules from calculus. So we'll get 0.06667 x cubed plus 10x evaluated from 0 to 10 feet. So a nice little refresher of basic calculus 1 or calculus 2 you should get 166.7 pounds as that equivalent point load, okay? Now what we need is the location of that point load, because we need to use that location as our moment arm. So that's going to be developed as x bar equals the integral from 0 to L, x times w as a function of x dx, and then divided by the total load, 0 to L, w is a function of x dx, okay? So let's set this up. That numerator is going to be 0 to 10 feet, and then we're going to have x times 0.2x squared plus 10 dx. And then we've already evaluated that denominator. That's just the 166.7 pounds, okay? And again, this is a pretty straightforward integral to take as that numerator. If we show a little handwork here just to refresh ourselves on how to do that basic calculus, we're going to say 0 to 10 feet. And of course, that's 0.2x cubed plus 10x dx. All I did was multiply through that x value divided by 166.7 pounds. And when we evaluate this integral, you know, it's a polynomial, so you raise it a power, divide by the new power. So you'll get 0.05 x to the fourth plus 5x squared evaluated from 0 to 10 feet, and then divided by 166.7 pounds. And so when we punch this through, let's see what we get. 0.05 times 10 raised to the fourth power plus 5 times 100, and then divided by 166.7. So you get pretty much right at 6 feet, okay? So if we were to draw this equivalent system, what would that look like? Well, the equivalent system, as a free body diagram, of course, will look something like this. You have 166.7 pounds, and that's located 6 feet away from point A. And we know it's 6 feet away from point A because that was our origin, right? We had a location variable x right there. Now what we're still trying to find is AY and BY. We already know that BX is 0. So from here, all we got to do is apply some equilibrium equations. So I can say sum of the moments about point A equals 0, taking counterclockwise positive. And in doing that, I'll have negative 166.7 pounds times 6 feet. And then plus BY times 10 feet equals 0. We'll do a little bit of rearranging here. And so we'll say 166.7 times 6 divided by 10, and punch that in one more time. 166.7 times 6 divided by 10. Yeah, I missed a decimal there. Equals 100 pounds reacting upwards. And to get AY, I'm going to say sum of the forces in the y direction equals 0. And that'll give me positive AY minus 166.7 pounds. And then plus BY, which is 100 pounds, equals 0. And do a little rearranging, and we'll get AY is 66.7 pounds, also reacting upwards. So my final solution, if I write the summary here, I'm going to have AY is 66.7 pounds reacting up. BX is 0, and BY is 100 pounds, also reacting up, and that's what I would box in as my answer. If you found this example helpful, please hit like and subscribe, and be on the lookout for other content like this, and thank you for watching.